Assalamualaikum. We Nur Elisha, Nurul Izzati and Nur Elisha as a group will be presenting on the topic the creation of synthetic insulin through recombinant DNA technology. Diabetes is a chronic condition characterized by high blood sugar level, hyperglycemia, due to inadequate insulin production or insulin resistance. Before the discovery of synthetic insulin, patients with diabetes had limited options for managing their condition, including extreme dietary restriction, low success rates in controlling blood sugar, and high risk of complication. Why synthetic insulin was needed? Limited supply. Insulin was previously sourced from animal pancreases like pigs and cows, which provide a limited amount and could not meet the growing demand. Allergy reaction. Animal insulin was not identical to human insulin, leading to allergy reaction in some patients. High cost. The process of extracting insulin from animals was expensive and inefficient.
So now let's move on to the procedure of how DNA recombination is utilized in the production of synthetic insulin. The first step is known as gene identification and cloning. So the gene is known as INS. It is isolated from the human DNA and then synthesized and amplified using PCR to produce a larger quantity of the gene sequence. The second step is known as recombinant plasmid construction. The gene is inserted into a plasmid vector that is capable of replication within a bacteria. Before insertion, restriction enzymes are used to cut both the plasmid and also the INS gene at specific recognition site. The insulin gene is then ligated into the plasmid using DNA ligase to form recombinant DNA. Recombinant plasmid is then introduced into a viable bacteria, typically known as E. coli, through a process called transformation. This can be done through heat shock or electroporation, which temporarily creates pores in the bacteria membrane, allowing the plasmid to enter the cells. The bacteria then incorporates the recombinant plasmid, begins to express the insulin gene. Third step is known as transcription and translation. Inside the bacteria cells itself, the INS gene undergoes transcription, where RNA polymerase synthesizes mRNA, the insulin DNA template. mRNA is then translated by ribosomes into the persicker insulin peptide. The last step, or the fourth step, is known as quality control and formulation. The recombinant insulin is subjected to strict quality control, including size confirmation and high-performance liquid chromatography for purity, along with bioassays to confirm its biological activity. Once purified and tested, the insulin is then formulated into a stable, injectable solution suitable for medical use.
The creation of synthetic insulin through recombinant DNA technology support the achievement of the selected SDG, which is good health and well-being. This is because it saves life by helping people with diabetes control their blood sugar, reducing deaths and complications from the disease. Additionally, it contributes to better access to medicine by making insulin cheaper and more available, ensuring that more people, especially in poorer countries, can afford it. To conclude, recombinant DNA technology has changed the way insulin is produced, making diabetes treatment better and more affordable. By inserting the human insulin gene into bacteria, scientists can make these bacteria produce insulin just like the hummingbird does. This method is faster, cheaper, and more reliable than using animal insulin. It allows insulin to be produced in large amounts, ensuring that people with diabetes have a steady supply. This breakthrough has not only improved the life of millions of people, but also shows how powerful genetic engineering can be in medicine.
That's all from us, and thank you for your time and attention.